say anything too crazy. Okay, so, oh, okay, cool. So really quick, what's gonna happen is if I share my screen, just kidding, come on. All right, so the first thing that we were talking about was the linear regression. So this is actually how you calculate it. So for instance, if we have this example where it says the table gives you the price P in cents of a first class stamp over time, where T is the number of years since 1970, and then use the linear regression feature of a graphing calculator to find an equation of the line, best fitting line for the data. So I would make sure that I have a TI-83 calculator, and then I would write down these buttons, these keystrokes. So you're going to use that stat edit and then fill in list 1 and fill in list 2. And then you're going to find the equation by using stat calc. So just take a moment and write those keystrokes down, because you're gonna want to use them tomorrow or whenever y'all take them. Hey girl, hey. Okay, so these are the instructions for how to graph. Yeah, can you not see my screen, Zach? Okay, so you're gonna do the stat edit button, and then you're gonna fill in list 1, list 2, and then you're gonna hit stat calc. Okay, and that should pull up this A plus B thing on your screen. And then you're gonna hit stat plot and turn the on button on, obviously, for plot 1. And then you're just gonna hit graph. Okay. So stat edit, put in the list, and then hit stat calc. And I would try doing this on your TI-83 or TI-84. Sometimes they have like a couple other things that you have to do a little extra. So just keep that in mind. I think there's a difference between the TI-83 and 84 that's like 1 extra keystroke. So I would try practicing that. Okay, so I would write down on my paper, stat edit, hit stat calc, hit the stat plot feature, and then graph. Okay, and you can even try putting this list in and then actually check your work on here. Pause on this with you. So you can download a TI-83 with Wabbit Emu, and then using that linear regression. Okay, and I can come back to this to give you a little minute to practice it. Okay, but I want to hit a couple other things and then we'll come back to this. So conditional probability. Okay, so this is one that deals with like the given. So it's going to say something, something, something given that something else happened, right? Okay, so conditional probability is the probability of one event occurring with some relationship or more other events. So for example, if event A is it's raining outside and it has a 0.3 chance of raining today, event B is that you'll need to go outside, and that has a probability of 0.5. A conditional probability would look at these two events in relationship with one another, such as the probability that it's both raining and you'll need to go outside. Okay, so for example, your equation that you're going to use on this too is the probability of A given the probability of the intersection of A and B. Okay, so just like what they said in example 1, it says in a group of 100 sport car buyers, 40 bought alarm systems, 30 purchased bucket seats, and 20 purchased an alarm system and bucket seats. If a car buyer chosen at random bought an alarm system, what is the probability that they also bought bucket seats? So the first thing that you're going to do is find the probability of A. So that's also given in the question. So it's saying 40 out of the total 100, that's 0.4. So that's our probability A, which is this top fraction. In step 2, it says figure out what the intersection is. So the intersection of A and B both happening together is, it's given in the equation 20 out of 100 buyers. So they say 20 purchased both. Okay, and then now you plug it into your formula. And I'm sorry, I got these switched. Oh no. So I've got the intersection of A and B divided by A. Woo, dyslexia at its finest, y'all. Okay, so we got 0.2 divided by 0.4, which equals 0.5. And this is the probability of B given A. Okay. And I pulled this one from a progress check for probability. So it says, consider rolling 2 number cubes, each of which has its face numbered from 1 to 6. The cubes will be rolled and the sum of the numbers landed face up will be recorded. Let event E represent the event of rolling a sum of 5. How many outcomes are in the collection for event E? All right, so let's think about it. We've got 2 cubes and they're all 1 through 6, right? Okay, so if I roll, these are the potential outcomes. I could get a 1 and a 1. I could get a 2 and a 2. I could get a 3 and a 3. I could get a 4 and a 4, right? 5 and a 5 and a 6 and a 6. Okay, now none of these equal 5. Well, then I could roll a 1 and a 2 and a 2 and a 3 and a 3 and a 4 and a 5 and a 6. Well, which one of these equal 5? One of these. Okay, then I could roll, try and come up with any other outcomes. 2 and a 3. Nope, I already did that one. 2, 3. Yeah. So that one's going to equal to 5. But now we want to list out all the other outcomes. Okay, so let's think about those. Sorry. The options for this question are going to be, and I haven't pulled up, sorry. Are 1, 2, 4, 5, or 6. We did miss a few. Okay, so we got 1, 2, 4, or 6 as our options. Okay, and right now we're probably picking 2, right? However, are there any other outcomes that we could potentially have on this one? Well, what if we switch these? Sorry, hang on. Okay, but let's think about this. Let's call this die 1, and this is die 2. Okay. What if we switch these? What if we had 3, 2? Well, that still equals 5, right? Same thing on the other one. We could have 4, 1. So how many outcomes could we possibly have? Really 4. Okay. So it should be this one. And I know that's a little much because it's like no one thinks about switching these, right? Yeah, do count the repeats. Yeah. Because you're looking at how many outcomes are in the collection for event E. So you're recording all of the potential outcomes. Okay. So what's the probability of the coffee of the day not being a light roast or a dark roast? Okay, so let's think about it. We've got 0.15 chilling over here. We've also got this 0.25 chilling over there. That's dark roast and light roast. So we want the probability that it's not that. So we're going to take 1 minus this total probability, right? Which is 0.4. So what's 1 minus 0.4? 0.6. Yeah, there you go. Go ahead. Good job. Okay, so it says Amy has 12 brown golf tees, 8 white golf tees, 10 red, 6 blue, 12 green in her golf bag. If she selects one of the tees from the bag at random, what is the probability that she selects a tee that is not brown or blue? Okay, so what's the probability of her pulling a brown one? Okay, so let's think about that. Well, 12 potentially out of how many total golf clubs? 12 plus 8 is 20, 20 plus 30, 10, I'm sorry, 20 plus 10 is 30, 30 plus 6 is 36, and then 36 plus 12 is 48. Yeah? Is that what you said? Hang on. We'll get there. And then you've also got the blue, right? Okay, so blue, 6 out of the 48, right? Okay, so we've got 12 plus 6, which is 18 out of the 48. However, we want the ones that aren't blue or brown, right? Okay, so what we're going to do is we're going to say, okay, what's 48 minus 18? That gives us 30, right? Because we want the not brown or blue. And then now we want to simplify this, right? So both of these are divisible by 6, which is going to be 5/8. And what did you say what would you say the answer was? Okay, so it says at a local elementary school, 35% of all students have brown eyes, 45% have brown hair, and 60% have brown hair or brown eyes. A student will be selected at random from the school. Let E represent the event that the selected person has brown eyes, and H represent the event that the selected person has brown hairs. Are E and H mutually exclusive events? Okay, so first question is, what does mutually exclusive actually mean? What does that mean? So with mutually exclusive, you don't want to have like an overlapping. They can't have something that they share. So for instance, in this problem, you got 35% who have brown eyes, and then you got 45% who have brown hair, and then you got 60 who have brown hair and brown eyes. Okay, so then it's saying let E represent the event that the selected person has brown hair, or I'm sorry, brown eyes, and H represent the selected has brown hair. So the question is, are they mutually exclusive? No, because you got overlap, right? Because you've got this 60% here, you got this 45 here, you got 35 here. Well, if you add all these up, that's more than 100%, right? So how much percentage are they overlapping? Where they intersect, how much is that percent? So they're not mutually exclusive, and it's going to be that 0.2. And the reason why they're not going to be mutually exclusive is because they've got an overlap of brown hair and brown eyes, right? Okay. But how do we get 0.2? Okay. So what's going to happen here is students at a certain high school have an elective period where each student chooses an elective from among 4 options. Following table shows the number of students who selected each elective for the 1,500 students at the high school. So there's that. One student from the school will be selected at random. What's the probability that the selected student chosen, the student will choose the art elective and the music elective? Okay, so how would we go about doing this? We would, for each elective, 1,500 students. So this is 1,500 students. Got it. Okay. So how are we going to go about doing this? Let me give you a second to think. So for instance, it's talking about each student being 1,500, right? Or total number of students is 1,500. So each one of these students only gets to pick one elective, right? I mean, like theoretically, we would be able to pick two, but there's no overlap here. So what's the probability that they can do the art and music? 0, right? All right, so it says a high school theater club has 40 students, of whom 6 are left-handed. 2 students from the club will be selected at random, 1 at a time without replacements. That's really key. And then it says, what is the probability that 2 students selected will be both left-handed? All right, so there's going to be 6 out of 40, right? And then we're going to have another selection, and hopefully the first person that they pull is left-handed. But we're going to have 1 less this time. Okay, so now we have to find the common denominator and multiply and get it all done. So 6 times 39 plus 5 times 40 over 40 times 39. Then I go into my calculator and I'm like, if it'll load, Benjamin, stop. 40 times 39, which is going to be 1,560 in the bottom. And then in the top, it's going to be 6 times 39. 234 plus 5 times 40. 200. So that's going to be 434 divided by 1,560. Okay. And looking at my answer choices, which I don't have posted on the screen. So can I simplify that at all? 434 divided by 1,560. That's going to give me 0.278. 0.278 roughly. Oh, okay. So going back into this, okay, you don't add these, duh, because it's without replacement. So you're just going to multiply straight across. So ignore my stupidity. And so 6 times 5 is going to give you 30. And then in the bottom, that's going to give you 1,560. Yeah. Okay. So when it says without replacement, you're always going to have 1 less. And then it's finding the probability of this both happening. So when they say both, that's going to mean multiply. I'm so sorry. Back to your geometry days. Sorry, that's the first time I'm looking at this problem. My bad. All right, so heights of women with a mean of 65 inches and then a standard deviation of 2 inches. If Annie's at the 99th percentile, then what is her height? So the first thing that I normally do with these is I draw that normal distribution curve, right? And I'm like, all right, 65. And then it's like 2 inches of the standard deviation. So 67, 69, 71. And I'll do the other one. 63, 61, 59. All right, so this is 1 standard deviation away. This is 2 standard deviations away. 3 standard deviations away. Okay, and just a reminder, so when you do this normal distribution and it's asking for the 99th percentile, and you don't have to use your z-score table just yet on this one. And really you don't have to use it since it's on a normal curve. So what's going to happen is from here all the way to here, if you know your empirical rule, that's that 68, 95, 99.7. Well, if you know that, then she's going to be closest to her height for 70 inches. Okay. you're trying to draw the curve for 0.3 to 1.05 pounds for this weight of squash. Okay, so you're going to draw the normal curve for this. So take a moment, try to think this one through. Okay, so in order to do this, I'm going to drop the mean, right? And that's just mu, right? And then I'm going to go up 0.25, down 0.25, down 0.25, up 0.25, and then I'm going to shade between the two numbers that they give me. Okay. One thing to mention is mu plus standard deviation. That's this section right here. Mu minus standard deviation, that's this guy over here. Okay. So just make sure you know how to read that notation. Okay, so you don't necessarily have to plot the residual, but there should be no pattern in the residual plot when you're trying to do a linear relationship or a linear model. Okay, it's like it's going to be dots all over the place. Okay. Yes, this one. Okay. Let's see. Okay, so really quick on here, what's going to happen is you've got a mean of 84, standard deviation of 7.4, and you want to find the score X above which 33% of the scores fall. So you want it above that 33%. So what you're going to do is you're going to have X minus X bar divided by standard deviation. So X minus 84 divided by 7.4. Then you go into your fancy dancy z-score table, okay? And so when you come in here, what's going to happen is you're looking for 0.33 on this z-score table. Now remember, depending on the z-score table, it might give you a little bit of a difference, but that's okay. So 0.33, that's in here. Yeah. Okay. So that's 0.6293, right? Okay. But remember, we went above. So that's going to give me 1 minus 0.6293. So 1 minus, come on, move out the way. So we've got 1 minus 0.6293. What does that give me? Got a calculator on top. There we go. Give me 37. Hold up, pause.